All right, I'm doing the Unit 9 test review. So question number 1 here says to solve this equation here by factoring. Since it wants us to solve it by factoring, we're just going to do what we did last unit. We see that we don't have just x squared by itself. We see zeros over here, so that's good. So I'm going to take these two numbers, we're going to multiply them. So we're going to do 2 times negative 4 is negative 8. And we got to find things that multiply to negative 8 but add up to regular 7. So I think 8 and negative 1 is probably going to work out. 8 plus negative 1 is 7, so that's good. Remember, since we got the 2 out there, we're not allowed to just go ahead and write down our answers. So we have to rewrite this as 2x squared plus 8x minus 1x, and then we've got the minus 4 is still here too. So we have to do our double GCF. It's been a while since we did this, but we got the 2 and the 8. We can divide those both by 2. They both have the x's, so I'm going to get x, 2x squared divided by 2x is x. 8x divided by 2x is 4. From our other two parts, they don't really have anything in common, but they are both negative, so I may as well take a negative 1 out. So I get x plus 4. And because I did that, I can see that the two x plus 4s are the same. So I can pull those out as my first set of parentheses, and then the second set of parentheses is going to be this 2x, and then the minus 1. So it's going to be those two outside parts. There we go. So we got our answer. So we solved that by factoring. Again, if we want to double check that, we saw we could kind of double check it with the graph. So 2x squared plus 7x minus 4. So 2x squared plus 7x minus 4. We don't want to put in the equals 0. That's not going to help us out too much because we want to be able to see the parabola that we make. We see we get two zeros. So our 2 points we get are negative 4 and 0.5. So if we look at our answers, remember we said, oh, negative 4, that's just the opposite of plus 4. So that works out. That one makes sense. The 0.5 is a little weird because we can't really write x minus a half. That doesn't really work out. But if we do solve this out, we would get a half. So that would work out too. Oh, I guess we aren't done yet. Good thing I reread the question. We have to solve it. We factored it. We didn't solve it yet. We still got to get those two answers. Whoops. Almost went too fast. All right. So this equals 0. All right, so we can use our zero product property here. X plus 4 equals 0 to get the negative 4. Good thing we double checked. So negative 4 is one of the answers. And this one, to get the 1/2, we're going to go 2x minus 1 equals 0. We're going to add 1 to both sides to get 2x equals 1. Divide both sides by 2 to get x equals 1/2. All right, good thing we double checked because that's the actual answer that we want to get. So now we're all set. We got our two answers. And again, we did double check. We did get the two answers. So we know what the two answers should be. But this one does say to do it by factoring. So we did have to wanted to show the factoring out. All right, for number 2. Number 2 says find the solutions of x squared minus x equals x by graphing. So this one tells me to do it by graphing. So I'll just follow their instructions and do it by graphing. So x squared minus x equals x. Remember, we want to put those on opposite lines. We don't want to put those all on the same line because we want to find that parabola, and we can see where that meets the line because x is the shape of a line. So it's at 0 and 2. Now we want to go for the x values. It's a little bit weird because the x's and the y's are the same on this one. But the only coordinates that we need, because there's no y's in the question, the only coordinates we want are the x's. So our two answers are going to be the x coordinates. So let's just go ahead and get rid of our y's because we don't really want to look at those. So our two answers are 2 and 0. So 0 and 2. Those are the two answers that we want. Again, we want the x's, not the y's, even though they did turn out to be the same this time. All right. For number 3, what are the coordinates of the vertex of the graph? Y equals x squared plus 2x plus 8. If we want to do it by hand, we have the formula x equals negative b over 2a. Remember, when we do our quadratic formula, this is a, this is b, and this is c. Now, c doesn't matter for this equation, which is kind of nice. But we do have negative b, so negative 2 over 2a, so over 2 times 1, is -1. So we get -1 for the x-coordinate. To get the y-coordinate, we plug -1 in. So -1 squared plus 2 times -1 plus 8. So 1 minus 2 plus 8 is 9 minus 2 is 7. So the answer should be -1, 7. Now again, it does say to find the vertex. So our other option, if we didn't want to do it by hand, is to graph it. So we can make a graph out of this one too. So let's go ahead and get rid of these ones. Those were nice. But x squared plus, it's 2x plus 8. Is that right? That doesn't sound right. Let me double check. X squared plus 2x plus 8, yeah. We don't see the curve. Well, it's a good thing we did it by hand, but remember what we expect. We expect it to be at -1, 7. We kind of expect it to be up here, and that's where it is. So it is hiding up there. So we could also do it graphically if we want to get that. So we can also get the answer graphically. So remember, this time it's going for the vertex. Vertex is always the top or the bottom. So there's the bottom of the parabola. So we get our nice little vertex at -1, 7. All right, for 4, it says write an expression for radical 128 without a perfect square on the radicand. So this is what we did in class where we had to split it up. So if we think about our chart, if we want, we can just go with 4 because it seems like that's even. So 4 is a pretty safe bet to pick. So if we do square root 4, we have to do 128 divided by 4, so that's 32. So this is good because that's 2, but this is still a little bit large, and we can actually break this up again. So 32, we could break it up into 4 and 8, because 4 times 8 would be 32. So this part's actually 2, but 8's still a little bit large, so we could break it up again. So we can do 4 again, and this time we get left over with a 2. So the square root of 4 is 2. This 2 we can't do anything with, because 2 would be outside of our chart. So in our chart, we kind of used 4 a whole bunch of times, which that's fine. So our final answer is going to be the black 2 times the purple 2 times the blue 2 times our leftover radical 2. If we combine them all, we get 2 times 2 times 2 is going to be 8 radical 2. So that's if we wanted to go with the chart. So that would use all the numbers in the chart. If we wanted to go a little bit faster, we could use one of the advanced moves. We could say we got 128, and we could know that this is actually 64 and 2, because the square root of 64 we know is 8. And that pops the answer out in one move. So if you didn't want to do 3 different sets, if you know that 64 works out, you can try your higher levels of perfect squares. So that's it. Either one is a correct answer. I'll circle the one in red over here too. We can't put this one in the calculator because it wants it to be written as an expression. It doesn't want an approximation. So approximation would be okay for a calculator. You can definitely use your calculator to divide though if you want. For 5, which equations have only one real solution? Select all that apply. So this one looks kind of tough because these equations are not very friendly if we want to use our discriminant, which is what we should probably use if we're doing it by hand. But we'll go for it. So for part A, we want to get everything on one side. So minus 4x minus 1. So for part A, we're going to end up with 4x squared equals 0. We can divide both sides by 4. X squared equals 0. But here, if I square root both sides, I get x equals plus or minus 0, but plus and minus 0 are the same. So that's what we want, because we want one real solution. So I think that's a good pick. I'm going to go with A. Since these are the same, that's one solution. I'll check out B next. So for B, again, same idea. We have to move everything over to the same side. So if we do that, we get left with 2x squared equals 0. And it looks like we're getting to do the exact same stuff. We just divide by 2 instead of 4. So we get x equals plus or minus 0. So B looks like it's going to work out also. If we try C, so we got 4x squared equals 1. Remember, the goal is to get the x squared by itself. So the reason I subtracted this stuff away was to kind of try and get these x squareds by themselves. X squared is almost by itself. I actually want to divide both sides by 4 here to get x squared equals 1/4. And now if I square root both sides, I'm going to get x equals plus or minus, there's no more square root. Square root of 1 is 1 on top. Square root of 4 is 2 on the bottom. So that's got 2 answers. It's got plus a half and minus a half. So we don't want that one. All right, and then we're left with choice D. So choice D, again, we have to get all the, ooh, that's going to be a tough one because we got to get everything by itself, but that doesn't work. Because if we were to add everything, we'd have x's on both sides. So this is one of the long ones. We might have to factor it. Well, it seems like that might be possible. So we got things that multiply to 4 and add up to 1. I'm not really sure. So I think for D, what I'm going to do is I'm actually going to graph it. I'm going to graph it and look at the solutions on the graph. Actually, let's keep doing it by hand. Since it's set up, let's change it. We're going to do A, we're going to do B, and we're going to do C. We're going to find our discriminant. So our discriminant is B squared minus 4AC. Because if this is equal to 0, then we'll have one real solution. So negative 1 squared minus 4 times 4 times negative 1. So it's 1 plus 16 is 17. 17 is not 0. So it's not going to be one real solution. So with 17, this is positive. So we'd have 2 real solutions. So there we go. So that's how we can do it by hand. Obviously, if we want to graph it, also a good choice, good graphing candidate here. So this one's going to be a little tough because we want to move everything over to the same side before we graph it. So I'm actually going to come down here and graph what I've got here, 4x squared equals 0. And I don't graph the 0, so 4x squared equals 0, not equals 0. Just 4x squared, and we can see that we get just one place where we hit the x-axis. So we can do it that way. My other option is if I want to do it before I simplify, it's 4x squared plus 4x plus 1. And then what it's equal to goes on the other side, 4x plus 1. And this is a little bit hard, but we can see that line's just tangent right there. So it just kisses the graph, but it doesn't really intersect. They just kind of touch once, and then that's it. So intersection would be if they kind of crossed, but it doesn't really cross. It just barely taps it. So it just gets close, and it does touch, because we can click on that point, even though it looks like it's the y-intercept. That is where the two lines actually touch. So that's how you could figure it out with the graph. Just to see the counter example, let's check out this 4x squared equals 1. So we get 4x squared. And we have to remember, if we want to put 1 into this calculator, we can't just put a 1 like we could with the TI. We have to do y equals 1. And we can see, oh yeah, that has 2 answers. So that intersects twice. Because remember, the solutions are where they intersect. Let's check out D also, since that one was a little unsure. So 4x squared minus x minus 1. We're going to get rid of this 1. And again, since everything was on the same side, we're just looking for the zeros. And we can see there, yeah, those don't look like they're going to factor very nicely because those are decimals. But there are 2 of them. So we were right with the discriminant to figure out there were going to be 2 of them. So don't want to pick that one because it wants only one solution. All right, for number 6, it says, what are the exact solutions of this equation? So chances are we're not allowed to graph it because it wants the exact solutions. So our answer should have a square root in it. So we want to get everything on the same side. So I'm going to minus 11 both sides. So we're going to have x squared minus 6x minus 11 equals 0. So our first option would be to try to factor it, but I'd have to find things that multiply to negative 11 and add up to negative 6. The only things that multiply to negative 11 are 11 and 1. That's not going to give me 6. So that method's out. So we're probably going to just go ahead and throw it into the quadratic formula because that will give us the exact solutions. So our quadratic formula would be negative b plus or minus the square root of b squared minus 4ac all over 2a. So we're going to use the big one. So this is going to give us our x's. So if we plug everything in, remember we're going to get 1 for a. B is going to be negative 6. C is going to be negative 11. So we got negative 6. Remember, we don't put any of the x's into this equation. The x is over here. That's where the x lives. So then we get plus or minus the square roots of b. So b is negative 6 squared minus 4 times a is 1, times c is negative 11. And we have to divide that all by 2a. So 2 times, and a in this case is 1. So while it looks like it's a lot, again, you can let your calculator handle it from here. I like to simplify it a little bit to give my calculator a little bit of a break, because negative and negative is just going to be 6. So that way I don't get too confused with plugging in too many negative signs. I like to simplify in here too a little bit. 6 squared, negative 6 squared is 36. And 4 times 1 times negative 11 is going to be plus 44. This is going to be 2. I'm going to be even super nice to the calculator and go 6 plus or minus square root of 80 over 2. Now here's where I would recommend you put it in the calculator, because a lot of people make a mistake here. A lot of people just do 80 divided by 2. You don't want to do 80 divided by 2. So we're just going to put it in right here. We've kind of taken care of by hand all the places where usually we'll make some mistakes with inputs. So I'm going to do it first with the plus. So we're going to do 6 plus square root of 80. Oop, I forgot to make my fraction first, but that's okay. We can do that. Over 2. And so we get our answer. Well, wait a second. That doesn't work out because we didn't want the decimals. Uh-oh. I guess we got to go back over here. We can't do that because we can't have the decimals. All right, well, let's keep going then. So we got to take our radical 80, and we need to then simplify our radical 80 as much as we can. So if we simplify our radical 80, we got to go back to our chart and think from our chart, what can we divide this by? I think 4 is going to work out pretty well. So we get 4, and we'll get 20. So that gives me 2. But radical 20, we could do another 4 with a radical 5. So that's going to be another 2. Radical 5. So square root of 80 is equal to 4 radical 5. All right. That looks pretty good. So we get 6 plus or minus 4 radical 5 over 2. That looks pretty good, but there's one more thing we could do. We could actually divide everything by 2. We can actually simplify everything. Now we're allowed to divide by 2 on the outside. We can't divide on the inside, but we could divide on the outside. To give us our final answer, 3 plus or minus 2 radical 5 over 1, but we don't need to write the over 1. So 3 plus or minus 2 radical 5. All right, now this is kind of fun because we can actually use the decimals to help out. So if I was unsure if I did all this right, we could put in 3 plus 2 square root of 5, and we see we get the same decimal. So that tells me that I did the simplifying right. I didn't make a math error from this step over to my final answer. So there we go. We got our result. Took a little bit of work by hand, but when we're doing the exact solutions, sometimes you got to do them a little bit by hand. So that's what we want to do for the exact solutions. For number 7, it says solve the system of equations. So we get our choice. We can either solve it with substitution or elimination or with graphing. If you want to do it by hand, probably since they're both y equals is, well, they're kind of stacked as well. So substitution or elimination would be about the same. X squared minus 3x. I can minus x from both sides. 0 equals x squared minus 2x. I see I've got a GCF here. And then I can use the zero product property. X equals 0. X minus 2 equals 0. X equals 2. But again, we got x's and y's, so I need to get coordinate pairs. So I got to plug my 0 back into the equation. So that means I'm going to get y equals 0. So 0, 0 is my first answer. And then I got to plug this one back into the equation. I'm going to get y equals 2. So I'm going to get 2, 2 for the second answer. This saying, that seems suspicious. That's like what one of the other ones was. Wasn't the other one we did 0, 0, and 2, 2 when we went back here? Yeah, this one was also 0, 0, and 2, 2. That's kind of weird. All right, but that's okay. Let's actually graph it. Let's double check because now I'm a little bit suspicious of that. So we got y equals x. Y equals x squared and 3x. Was that it? X squared minus 3x. Oh, I was right. Look at that. They're telling me it's 0, 0, and 4, 4. Oops. What did we mess up? X squared minus 3x. So we did that. Oh, I see what I messed up. I messed up the negative signs. That's okay. We're allowed to make mistakes. That's supposed to be a 4. So we can fix that because negative 3 minus 1 would be negative 4. So x minus 4. So this is x minus 4. So we have to plus 4 both sides. So we get x equals 4. Plugging it back in, we get y equals 4. And so this should actually be 4, 4. So again, good thing we double checked. So the graph is really helpful for this test. We can figure a lot of things out. And we can check our work pretty well if we use the graph. There we go. Now this time, unlike the other question, since the y is a part of the question, see how the y is right there? We do want to include both parts. We have to include the x and the y this time because the y is part of the question. So there we go. All right, for number 8, which lines intersect the parabola at 2 points? Select all that apply. So I'm feeling, since it tells me the keyword intersect there, I kind of feel like this is going to be a good one to graph because it's going to be easy to see on the graph where they intersect. I don't think I want to have to do what I did here by hand all 4 times for each of the equations. That seems like that would be a bit much. So y equals x squared minus x plus 3. X squared minus x plus 3. And then the other ones I got down here, so I'm going to try a first, so negative x plus 2. That is 0 times, so I think that one's out. Right, because we want to find, we want 2 points. So this is A. A's out. All right, so we'll try B. We'll do plus 3. That's a pretty easy one to do. That only hits once. That's just one hit. So again, that's just that tangent line. Just taps it, but that's not what we want. We did not want that one. So we're not going to pick that one either. That one would be B, but that one's out also. So this one only hits 1 time. This one has to do 2 times. This is only 1. That only hits once. All right, well, I'm feeling pretty good about choices C and D then. So if those 2 didn't work, I'm feeling pretty good about these. That looks excellent. So we can see we hit 1, 2. We hit twice. So that's a 2 time. So let's go ahead and make that one choice C. So we got 1, we got 2. I'll circle my 1 intersection, I guess, with the red one. There's 1. And then choice D, I think, is probably going to work, but we'll put it in just in case. Yep, that's pretty easy. This one's got some weird decimals it gives us, but it does hit twice, and that's all that matters. So we're not looking for nice, clean answers. We're just looking for connections. So those look pretty good. Kind of out of space on my page, but we'll put it over here, I guess. Sorry to choice D, but we're going to hide you over here in the corner. So 1, 2. So there we go. So that's it. So a pretty good one with the graph. That's all we got for 8. So number 9, what is the graph of the quadratic function passes through the points 0, -4, and -2, 0. What is a 0 of the function? They kind of tell us. -2. That's pretty easy. That's just vocab, I guess, right? Because this is going to be the y-intercept because x equals 0. And when y equals 0, this is a 0 of the function. So we're done. That's it. That's a vocab question. Okay. All right, that's pretty quick. Number 10, what's the value of x in the diagram? So we got a right triangle. So for a right triangle, we got to do Pythagorean theorem. So we're going to do a squared plus b squared equals c squared. And the only one that really matters is the long side has to always be c. The other two don't really matter. I'm just going to make this one a and this one b. So I'm going to get 8 squared plus x squared equals x plus 2 squared. All right, well, this is looking a lot like one of those questions that we had on the last test, where we have to square kind of this part. We got to square this part. So we're going to get 64 plus x squared equals, and now this we can multiply out with the boxes. We can do the double distribute property. We could use the trick to get x squared plus 4x plus 4. But again, you could use any sort of method like x plus 2 times x plus 2 is x times x plus 2 plus 2 times x plus 2. So we distribute x squared plus 2x plus 2x plus 4, x squared plus 4x plus 4. So again, if you didn't have the trick memorized, you got to do a bit of extra work over here. But we just want to try and get x by itself. We can subtract x squared from both sides. That looks very convenient. So we get x squareds are just going to drop out of the problem. I can move the 4 over to the other side to get 60 equals 4x. Then divide both sides by 4 to get 15 equals x. So that's not too bad. Now again, a lot of people were very intimidated by the word problems on the last test. So if you can get it to here, you can fill in for a, b, and c. Let's check this out. 8 squared plus x squared. It's going to be one of the curves. Now, it didn't really show up, which again I'm a little suspicious about, but I do know 8 squared is pretty big, so it makes sense to not be on the graph right now. And then x plus 2 quantity squared. All right, well, I got my parabola, so I just have to find where this black curve is. So let's zoom out. I don't see it. Zoom out again. I don't see it. Zoom out again. I found it. All right, so I got to find where these two things connect. So let's zoom in a little bit. They're getting close. Still don't see the gray dot anywhere, though. There it is. There we go. All right, so the gray dot is all the way here at 15,289. All right. So that's where they connect here. So I guess we got our answer. And that matches up because that's exactly what we figured out. Just like before, if we look at our equation that we have here, 8 squared plus x squared plus x plus 2 squared, there's no y's in this equation, so we ignore the y's. 15 is the answer. So yeah, you can actually get this one with the graph too. So we can kind of avoid a lot of the algebra if we wanted to use the graph. So that's kind of the cool thing about this unit, and also Unit 8, which we didn't do too much in Unit 8, but it's about seeing how we can use some of these graphs to help us out with some of the algebra if we wanted to take an alternative strategy. All right, for 11, the graph's not going to help us at all here. It says rewrite the expression where x is positive without a perfect square factor in the radicand. So if we look on our outsides, we only have a 3. That's the only thing that's on the outside. So that's okay. On the inside, we got a 2 times 8 for 16. And then an x to the 3rd times an x to the 5th. We have to add these up. So we're going to get x to the 8th. This is looking really convenient because when we split this up into the 16 and x to the 8, square root of 16, we know that one. That one's just 4, because that's in our chart. X to the 8 is even, so we can just jump into 8 divided by 2 for 4. So we get x to the 4, and we're kind of done. 3 times 4 is 12, and then x to the 4th, and that's it. So that was a nice one. We saw some of them took a little bit longer, but this one, everything turned out to just kind of drop out of the square roots right away. So that was a really cool one. All right, for number 12, we have to solve another equation here. So this doesn't look bad at all. It looks like we're just going to do some distributing. We're good at distributing. So we get 12x minus x squared. And this is looking interesting. We get another 12x and then minus 9. So first thing I'm going to do, I see that I've got two 12x's. We're just going to minus 12x both sides to drop those out of the problem. All right, now we might be tempted to say no solution, but we do have this negative sign over here, so we actually have to divide by -1 first to get x squared equals 9. Square root both sides. X equals 3. And then since we're doing our algebra, we got to remember the plus minus on this one. Since we did a square root and we're not doing geometry, we got to do a plus minus on that. So there we go. Not too bad. Pretty quick one. But again, if it's a solve one, we can put in both sides. X times 12 minus x. And then the other side was 3, 4x minus 3. Let's go back home. All right. Do I have that in right? 3, 4x minus 3. All right. So let's see. Oh, there we go. We got to zoom out a little bit. All right. So let's see. Where we go. We got 3. We want -3 also. So it looks like we got to zoom out some more. Oh, there it is, all the way down there. So these ones were hiding. Let's zoom out even a little bit more to get our whole parabola on the screen. And there we go. We actually could graph to get the answers also. That one took a little bit of work, and it's easy to forget one of the solutions if we do it with the graph, but you can double check your answers with the graph. Again, kind of like the last one that we did with the graph. No y's in the equation, so we ignore the y's. So we get 3 and -3. So there we go. All right. For number 13, solve by factoring. So again, they want us to factor, so I'm going to follow the rules and I'm going to factor. So I'm going to minus 84 on both sides, because to factor I have to get everything on the same side. So x squared minus 5x minus 84 equals 0. And now I get to jump right into the chart. I got to find things that multiply to -84 and add up to -5. So that sounds like a little bit of a challenge. Well, I wanted to pick 8, but 8 doesn't work. So let's try 4. Maybe 4 will work. So 4 is going to go with 21. I got to make one of them negative. I got to make the negative the bigger one. So that's -17. So that's way off. All right. Well, that's okay. We always make a first guess. It looks like 12 might work out. So let's see. 12 times what would be 84? That would be 12 times 7. Again, 12, the negative has to go with the bigger one. That does give us -5. Nice thing is, even though this was kind of tricky to do, there's no number in front of the x squared, so we get to jump right to the answer. X minus 12, x plus 7 equals 0. And then since we have to solve, we have to use our zero product property. Oops, I went way too fast, but you could do. You could just solve it by inspection. But we can add 12 to both sides. X plus 7 equals 0. X equals -7. That's our two answers. So there we go. Again, if we wanted to, we could also check it with the graph. So x squared minus 5x minus 84. So again, we get our minus 7. That's one of the answers we got. And then 12 was our other choice. So I prefer to put it in after simplifying it. If you want to do it before simplifying it, remember you have to type in y equals 84. And now the problem is I have to go all the way up to 84. So that's why I'm not a big fan of this version, doing it this way. But you do still get the same x coordinates if you wanted. All right. For number 14, it says the profit from a business is described by this function, p of x, where x is the number of items made in thousands and p of x is the profit in dollars. How many items will maximize the profit? So the idea is that a maximum should probably be the top of a parabola. So this is either going to be the top or the bottom. So this is going to be the vertex. So maximize is going to go with vertex. So if I want to do this by hand, I'm doing negative b over 2a. So that's going to be, again, a is negative 3. B is 12. So negative 12 over 2 times negative 3. So that's going to be negative 12 over negative 6, not 16, which is equal to 2. So I know I get the maximum at 2. So I got to think. 2 is the x. So x is the number of items made in thousands. So that's actually the answer. So we're already done. So it's 2, but it's 2 in thousands. So the final answer is 2,000, not just 2. So there we go. If we want to double check, again, we can plug in this p of x, so negative 3x squared. And then let's see what else we got here. Plus 12x plus 75. And all right, well, looks like my maximum's already there, and yeah, it's at 2. So 2,000, and we'll get 87 is the y. So in this case, that's in just dollars. Okay, I guess if we sell 2,000, we'll get $85. That's not a lot, but yeah, maybe if it's something like a nail that you're selling, maybe selling 2,000 nails is not unreasonable. So they might not cost a lot of money to make. All right. For 15, we got to solve this. So the squared's already by itself, so I'm just going to go ahead and square root both sides. X plus 7 equals 7. And then we got to plus or minus this. Now I don't have x by itself yet, so I still have to do minus 7 on both sides. So I got to be careful here. I'm going to do minus 7 plus or minus 7. So negative 7 plus 7 is 0. Negative 7 minus 7 is negative 14. And those are my two answers. So we're done. Again, if we want to graph it, we can graph it. So x plus 7 squared equals 49. It's not deleting here. X plus 7 squared. And remember, y equals 49. And we can see the two dots right there at negative 14 and 0. So, I'm still quite zoomed out, so it shows up really fast on my screen. You might have to zoom out a bit. All right, pretty good. So 16, use the quadratic formula to solve this to the nearest hundredth. So this is interesting because it's telling us to use the quadratic formula, but it's also telling us to do it to the nearest hundredth. And those two things don't usually match up. So, I mean, you can really just put this into the graph and find the zeros if you want, since the answer is going to the nearest hundredth. But I'm going to follow their directions. I'm going to say, well, let's use the quadratic formula. So negative b plus or minus the square root of b squared minus 4ac all over 2a. So we got 1x squared, so that's a. We got 14 x's, so that's b. C is going to be 44. So I'm not liking those numbers, but this is what we're going with right now. So b is 14 plus or minus square root of b is 14, so we have 14 squared, minus 4, a is 1, and then c is 44. All right, all over 2a. Well, at least the bottom's nice. All over 2 times 1. All right, so we got to do the parts. Now it wants the nearest hundredth, so I'm going to just go ahead and start throwing things into the calculator. I think I'm going to put the whole thing in this time. I just have to be very accurate when I put it in. So let's go for it here. So we have, I'm going to start my fraction this time. So negative b plus, remember you can only do one at a time, the square root of b squared minus 4 times a times c all over 2a. All right, so I'm going to copy that and paste it, and now I'm just going to do it with a minus sign. All right, so I got my 2 answers. Now, I'm not sure if those are the right answers, because again, those just look like a bunch of gunk to me. So let's see what happens when we plug it in. So x squared plus 14x plus 44. So do we get the same decimals? So we get these two as the answers, and yeah, that's actually what we got. So that's how I can feel confident that I typed it in right, that I did the quadratic formula right. So let's go ahead and grab a screenshot here. That's quite big. We don't need that to cover everything. But we still got to answer the question. So we got everything right. We have the 2 right answers. And this last part, it says it needs it to the nearest hundredth. So the reason it's going for the nearest hundredth, I'm going to tell you this, is because Desmos gives you to the nearest thousandth. And sometimes they round the thousandths wrong. Well, they don't round it wrong, but they round it, and then you might have to double round it to the nearest hundredth. So that's why this one question is going for the hundredth, because it's trying to trick you a little bit into throwing in the thousandths, or to do a double rounding if this ends in like a 5. It might have been rounded up to 5 from like a 4-9, but then it needs to get rounded down. So we really have to look over here. And we're going to the thousandth, which is going to be 2 decimals, so 4.76. And then 3 does not round the 6, so negative 4.76. Here I've got negative 9.236. And then here the 6 is going to round the 2.3 up to 2.4, or I should say down to 2.4 because it's negative. And those are my 2 answers. So those are the 2 that we want to do. Again, we do not want the y's. There's no y's in this question at all, so you should never go with the y's. We're not going with the y's on the graph. We're just picking the x's, which is another reason to just do the quadratic formula. All right, for 17, it says, which of the following are factors of x to the 6th minus 16? Select all that applies. This one's pretty tricky because we can't really use the graph because, again, we're just going for the factors. So we're only going for parts. So we actually have to factor this by hand. Now, the nice thing is I can see the 16. The 16 is very square rootable. So I'm going to try and square root both parts, because we said that we had our form of a squared minus b squared is going to be a minus b times a plus b. So I said this was very square rootable. That's just going to be 4. So I know I could put 4s in for these b's. Now, can I square root the x to the 6th is the question? The answer is yes, because we can do 6 divided by 2 is 3. So the square root of x to the 6th is x to the 3rd. All right, so we have our 2 factors, and they are choices A and D. Now, again, there's no real good way to check B and C to see if they are or aren't. You just have to kind of factor it by hand and then go for it. So that's what we got. That's it with 17. For 18, quadratic function d is equal to negative 2x squared plus 10, models skateboard distance in feet. From the bottom of the hill, x seconds after the skateboarder starts moving down the hill. After how many seconds is the skateboarder 1 foot from the bottom of the hill? So if we want the skateboarder to be 1 foot away, we're going to take the 1, and we're going to plug the 1 in for the distance. 1 equals negative 2x squared plus 10. So here we got a couple options. If we want to solve it by hand, we're trying to get the x squared by itself, so we can minus 10 on both sides. So we get negative 9 equals negative 2x squared. We can divide everything by negative 2. So 9 divided by 2 is going to be 4.5 equals x squared. And we're going to square root both sides. Now, we got a little bit of an issue because square root of 4.5 doesn't seem very nice. So we just have to figure that out. So we got to do square root of 4.5. So it looks like about 2.12, so about 2 seconds. Now, again, we know it's not going to be the negative version on this one because we can't do negative time. So that seems pretty reasonable. Like, that's okay. That kind of makes some sense. That's a reasonable number of seconds. If we were unsure, again, what we would do is we would put this in, negative 2x squared plus 10. And we want to find out where we're equal to 1, so we would put in y equals 1. If we look, yeah, that looks like that's right where we had it, about 2.12 seconds. Again, we don't need the negative one because negative time doesn't really make sense here. But yeah, about 2 seconds, 2.1 seconds. So that's what we got. So that's it. So a pretty quick one. For 19, find the value of c that makes this thing a perfect square trinomial. All right, so there's a lot of ways that we could do this one, but since they gave us the information that we're going to get a perfect square trinomial, that was when we did our square roots of the first and the square root of the second, and we had to equal the middle part after we multiply by 2. So for this one, we want 2 times the square root of 25x squared times the square root of c to be equal to 70x. So that seems like a weird equation. We got a lot of letters in there, but let's see what we can work with. So this one's kind of nice because this one we can turn into square root of 25 and square root of x squared. Nothing else can change at this point. The c is a different letter, so the c gets to stay in its own little radical over here. But when we simplify, square root of 25 is going to be 5. Square root and x squared are going to cancel, or you could divide by 2. We're going to get x. Square root of c, again, that's its own little thing because it's its own variable. Now, if we do 2 times 5 times x, that's really 10x. And that's going to be 70x. So then what we want to do is we want to divide both sides by 10x. So we're going to get the square root of c is equal to, now here x and x are going to cancel. 70 divided by 10 is 7. So we get the square root of c is 7. We don't want the square root of c, we want to get c itself. So unlike pretty much everything we've done in this section, we're going to undo the square root by squaring both sides. So we're going to get c equals 49. And there we go. We got our answer. How would we double check this? Well, we would double check it with the graph, same way as most of the things. We would put in 25x squared plus 70x plus, we picked 49. And what we would be looking for is we're looking for just 1. So a perfect square trinomial should just hit once. So we can see that we've got just 1 hit on the x-axis. We have just 1 answer, so that works out. That does give us a perfect square trinomial, because in this section, the idea is a perfect square trinomial will give us the same answer twice. So it's just going to hit once. It's just 1 x-intercept. And that's what our graph has. So that's how we know we did it right, because we have just 1 x-intercept. All right, moving down to 20. Another one of these that we can't do with the graph, but that's okay. We know we've got the 2. That's the only thing that's on the outside. Square roots, we got 6 and 18. So 6 times 18 would be 48 and 60 for 108. With the x's, we got x3 and x5. I think that was in the last problem. We had 3 plus 5 to get 8. All right, so 2. This one's a little bit harder because 108 is not in our chart. But x to the 8 actually works out really nicely. So x to the 8, we can do 8 divided by 2 to get 4. So this part's really fast. The 108, though, we got to think about what we could divide 108 by. Again, I see right here that it's even, so I'm trying 4 right away. Might not work, but I'm feeling pretty confident about 4 because the 108 is even. So 108 divided by 4, so that would be 25 and 2 for 27. Again, we said that this is going to give us a 4, so that's just x to the 4. So this is going to be 2 times a purple 2 from square root of 4. Now, 27 is still a little bit big. If we think about our chart, we actually have a 9 that we could use. This x to the 4th is still hanging out. So now we've got the blue 2. We've got the purple 2. From the 9, we've got a purple 3. We still have the radical 3. And then the x to the 4th is still over here in green. We got that out of the square root. So final answer, we just cleaned everything up a little bit. So 2 times 2 is 4, times 3 is 12. X to the 4th is not in the radical, so we can put that right there. And then radical 3 at the very end. So there we go. Now, if we wanted to, we could have gone a little bit faster. So again, just like we did this in 2 stages, if we wanted to try some of our larger radicals, this actually is square root of 36 and square root of 3, because 36 times 3 is 108. And again, we could have jumped to 6 radical 3 right away, and then times the blue 2 would get us the 12. So that would have been our other choice if we wanted to go a little bit more advanced, which you're allowed to do. All right, 21. We got to find the value of this expression. So this is one that looks scary, but you could, if you just want to put in the calculator, just put in the calculator. Why is this here? I mean, next year you're going to learn about the distance formula, and this is just a setup for the distance formula. So it's just having you practice a little bit for next year with the distance formula. But not too bad. 3 plus 2 is 5 squared. 16 minus 4 is 12 squared. Oh, and we know this one. This is a classic geometry question. You say the word geometry and the computer just starts to blow up. All right, but it is a geometry question. Didn't blow up this time. So this is a typical 5, 12, 13. The answer is going to be 13. You do enough of these in geometry, you'll know what the answer is going to be. But let's go ahead and go through the calculation. So 5 squared is going to be 25. 12 squared is 144. 25 plus 144 is 169. Square root of 169 is going to be 13. Now, technically, we're still in algebra, so we still want to do the plus or minus at the end here. But this one is actually probably okay if we just put the, we'll just do it for, just to be safe, we'll put the plus minus. Again, I know it's supposed to be a geometry question based on what it looks like, so you should get regular 13, but we'll put the plus or minus 13 since it is algebra 1. Again, you can just throw that all straight into a calculator if you really want. All right, number 22. So the zeros of our quadratic function are 9 and -4. Which one could be the function? Select all that apply. So this one wants us to go ahead and factor all of these to find out what the answers are, or use the quadratic formula, or graph it. Since we're doing them by hand, we could just factor them. We're finding things that multiply to 36 and add up to 5. -5 for part A. So let's see, multiplies to regular 36. But they both have to be negative. I don't really think that's going to work out. Because we got 1 and 36 would be 37. So 2 and 18 would be 20. 3 and 12 would be 15. So we got 4, yep, 4 and 9, because that's kind of what we want. We want to get this 4 and the 9, but that gives us 13, so that's not going to be good. If we get 6, we could do 6 and 6 for 12. So I never got -5, so this one's out. So we know we don't want regular 36, so I guess we're going to -36. So that's the next choice for part B. Now we have to get +5. Now again, I'm feeling that we want 9 and 4 as my answers here, so I got to get +5. So let's see, it's probably going to be 9 and -4, because 9 times -4 is -36. I need the 9 to be positive. Yeah, 9 plus -4 is 5. Since it starts with x squared, I can actually jump right to the answer. So that's perfect. X plus 9, x minus 4. We'll use our zero product property because we want the zeros of the function. So we get x plus 9 equals 0. And we get x minus 4 equals 0. So we get -9 and 4. But that's not what we want. We wanted regular 9. So that's out. All right, moving on to choice C. So with C, again, we still got to get to -36. But this time we want -5, but that's fine. We just flip-flop these. So -9 and regular 4. -9 plus 4 is -5. We get to jump right to the answer. So x minus 9, x plus 4. We use our zero product property. X minus 9 equals 0. X equals 9. Good, that's what we want. And on the other side, x plus 4 equals 0. Minus 4. So x equals -4. That's what we want too. So we are going to pick C. So C does work out. Now I still got to try out D. Remember, when we're going for the zeros, we're setting this side equal to 0. So 0 equals x squared minus 5x minus 36 over 5. This 5 is inconvenient, so I'm going to multiply both sides by 5. So I get 0 equals x squared minus 5x minus 36, but I already did that. That's the same as this one. So since C worked, D has to work also. So that's pretty nice. Again, if we don't want to do the factoring, we could do quadratic formula, or if we want to graph it, I'm going to graph C. So with C, we get x squared minus 5x minus 36. So we can see we get the two answers that we want, -4 and 9. So we could also graph it to double check. Where's my thing at? If I wanted to see when that didn't work, let's just do the minus and the plus. That one should be a little interesting. So if we do that, we actually get no solutions. That's all the way up the graph. So we could tell that's not going to work out because there are no solutions. We never hit the x-axis. All right. 23. Outfielder throws the ball to home plate. Ball's path is modeled by the graph of y equals 2x over 5 minus x squared over 500. X is the horizontal distance, and y is the ball's vertical distance. What are the coordinates of the vertex of the ball's path? So yes, we're going for vertex. If we want to do it by hand, -b over 2a is the equation we need. So we have to be careful because this is not in standard form. So standard form would be -1 over 500 x squared plus 2/5 x. So plus 0. So our A is actually -1 over 500, and our B is 2/5. So -2/5 over -1 over 500. Oh, times 2. Still have this 2 here. All right, well, if we simplify this down a little bit, this is 2/5 over 2 over 500, because the negative signs are just going to cancel out. So now the 2's cancel out. So we got 1/5 over 1 over 500. But if we actually were to divide this, again, I'm just going to do it all by hand. This is 1/5 divided by 1 over 500. So we do keep, twitch, flip, just like old school and elementary school. So 1/5 times 500 over 1. So 500 over 5 is 100. So I actually have the x coordinate as 100. I got to get the y, which means I got to plug the 100 in for the x's. So negative 1 over 500 times 100 squared plus 2/5 times 100 plus 0. All right, well, this is going to simplify a little bit. So 1 over 500, if I'm doing it without a calculator, I probably want to split that 100 squared up into 100 and 100, because then that 100 will cancel out 2 of those zeros. This is going to be 200 over 5. So then I have to do 100 times this. So that's negative 100 over 5 plus 200 over 5. So negative 100 over 5 plus 200 over 5 is 100 over 5, and 100 over 5 should be 20. So if I did everything right, which again, maybe with the fractions we might not be super confident, but if we did everything right, we should get 100 comma 20. So let's check. Let's just throw it in a graph and let's see what the vertex is. So y equals 2x over 5. So 2x over 5 minus, I think it was x squared over 500. Yeah. Okay, well, let's go home. So this is what it should look like. And that doesn't even look like a parabola, but we did see with the zoom outs, it did kind of have a little bit of a curve to it. And so there's our whole baseball's flight path. So very nice. Look at that, 100, 200. We did it. So right there, 100, 200. And something that's also cool about this is we can see the end of the ball is it went 200 feet in total. So it was actually a 200-foot hit or out, depending on if the outfielder was there. So, wait, outfielder is throwing it. It's not a hit. So yeah, that makes sense then. So throwing it 200 feet all the way into home plate. All right, very cool. So last one, 24, just find the discriminant. So this is pretty quick. We just have to know the discriminant formula. B squared minus 4ac. Remember, that's just the inside part of the square root. Otherwise, everything's kind of the same as quadratic formula. That's A, that's B, that's C. Again, we're not going to put any x's into this formula. So negative 7 squared minus 4 times 5 times, not 20, that would be a bit much. C is just 2 times 2. And so we get 49 minus 5 times 2 is 10. 10 times 4 is 40. So our discriminant ends up being 9. So that's it. It just wants us to use that formula. That's everything. So that's everything that there is. So you see there's a ton of graph questions if you wanted to use the graphing calculator. That's a really good asset on this test. The only ones that really you can't use it on would be, I guess, this one right here. And then also the ones where you have to simplify the radicals. But we did a really good job in class at simplifying all the radicals. So as long as we're pretty good with that again, as long as we didn't forget to just split up our numbers and our letters. Numbers, you use the chart, 4, 9, 25, 49. With the letters, with the variables. If it's even, just divide by 2. If it's odd, subtract 1, then divide by 2. But that's it. So this one should go pretty well. I think this is going to be a good test.